We have 2 log base what here? Base 10 of 2x plus 4 equals 6. So we take a look at our solving log sheet, and do we have a log on one side or a log on both sides? We have a log on one side. So we're going to go through, I'm going to show you guys how to use this card. At some point, obviously, before the quiz, you want to make sure to have these steps memorized. But the nice thing about this is it is very step-by-step. So as long as you can use the properties, you should be good to go. Okay, so the first step is to add or subtract to move the non-log term to the other side of the equation. So let's take a look at A here. Which side has the log term, left or right? The left has a log term, so I'm going to cover up the right-hand side. How many terms are on the left-hand side? 2. This is a log term. It's 2 times the log of a number, so it's a product, but this is the log term. And then I have this other term, which is just positive 4. Does 4 have a log with it? No. So I'm going to add or subtract to move it to the other side. So what do I do here? Subtract 4 from both sides. So we have 2 log of 2x equals 2. All right. Next step, so I've completed step 1. Step 2, I'm going to multiply or divide to isolate the log term. So let's look at the log term. And notice I have 2 times the log of 2x. So how do I isolate this log part? Divide both sides by 2. Good. So I'm dividing by 2 to isolate the log term. So now I have log of 2x equals 1. Next step, I change to exponential form. This is step 3, change to exponential form. So if you need to get your other note card out to remember, that's fine. Otherwise, first question is, what's the base? 10. What's the exponent here? Yeah, because logs equal exponents. Equals the only other number left, 2x. And then the last piece is to solve the equation. Well, what is 10 to the first power? Just 10. So this is 10 equals 2x. So how do I get x by itself? And therefore, x equals 5. Done. Crazy. We know it. Wild. Okay. C. So we're going to jump around. Jump over to C. Okay. Do I have a log on one side or both sides? One side. All right. Now looking at the left-hand side, how many terms do I have? How many terms? How do you know what's missing? The plus or minus. If you don't have a plus or minus, it's one term. A product is only one term, but if you're adding or subtracting, that's a completely different term. Now, so that means that I can skip step 1 because I do not have a non-log term on the log side. However, I do have another number with that log, and what is it? 2 times that. So for step 2, we're going to divide here by 2. So I get log base 5 of x equals 1. Step 3, we're going to change forms. Okay, what's the base here? What's the exponent? And then we get equals x. So x equals 5. E. Jump to E here. For E, do we have a log on one side or both sides? We have a log on both sides, so flip your card over. And here's how this works. If you have a log with the same base, so I have log base b of some number x, log base b of some number y, then x has to equal y in order for this equation to be the same. Okay, so that means that we do something we call dropping the logs. If you see this happens, you drop the logs and just set what we're evaluating equal to each other. Well, notice I have log base 5 on both sides, so that means I'm going to have x squared minus 3x equals 7x minus 21. So that's called dropping the logs. Drop the logs. All right, now what kind of equation is this now? What kind? What kind of equation? Is this linear? What kind of equation is this? Linear, quadratic, cubic, quartic, what kind? What kind of polynomial is this? It's quadratic. What's the giveaway? Yeah, we have squared. Anytime you have a quadratic equation, what is the first step? Set it equal to 0. So we have, we're going to subtract 7x, and we're going to add 21 to both sides. So then we're left with x squared minus 10x plus 21 equals 0. Now what? Now factor. What are the two numbers? Seven and 3. And what else do we know about them? To get a negative 10, they both have to be negative. All right, what property do we use? You know a ZPP? Yeah, you know me. ZPP, zero product property. So we know x minus 7 has to equal 0. X minus 3 has to equal 0. So one of these has to be true. If we're solving them, we get x equals 7. Or x could equal 3. It's wild. That's how math is, you know. It's like a party every day. Okay, here we go. G. For G, let's take a look. Do I have logs on both sides? No. So we go here, logs on one side, and then you're just going to look through the steps here. All right. First step, do I have a non-log term on the log side? So let's take a look. What is the log side, left or right? Left-hand side. How many terms are on the left-hand side? There's 2. Therefore, there is a non-log term. Step 1 says, what do we do to it? We add or subtract it. Now, is this 12 positive or negative? So what do we need to do? We need to subtract it from both sides. Okay, we're done with step 1. So for step 2, take a look at your note card. For step 2, we need to multiply or divide to isolate the log term. Well, what does that mean we're going to do then? By negative 3. Excellent. So we have log base 4 of 3x minus 5 equals, what's negative 6 divided by negative 3? Positive 2. Now we jump to step 3, which is change to exponential form. What's the first question? We're changing forms. What's the base? In this case, what is the base? What's the exponent? And what's left over? Okay, we want to solve for x, so what are we going to do to both sides? Add 5. What's 16 plus 5? 21 equals 3x. We divide both sides by 3, and x equals 7.